Okay, in this module we're going to walk through troubleshooting and support as a demonstration. So the troubleshooting process starts with localizing the problem. Is it the end user's device, the enrollment process? Is there a problem with the local network causing problems, maybe DNS or something like that? Is there a connectivity problem between the local network and the Zero Trust Exchange? If we've got connectivity, is it a problem with enrollment of the client, the authentication process? Or is there an issue with the Zero Trust Exchange connecting onwards to the internet, which could be a policy problem within your Zscaler internet access policy? Or is there a connectivity problem with private access? Again, maybe a policy problem or a challenge with the app connectors we need to investigate. So when we do that, we're then going to look at each of those areas, investigate which of those problem areas to look at, and capture logs or packet captures or inspection of each of those different issues. And then we're going to diagnose those problems and potentially update some configuration. So we'll take this from first principles and walk through the troubleshooting process. So here I have a Windows machine, and we're going to start with I'm going to bring up a command prompt because I'm interested to check things. First off, my IP address information. As you'd expect, I've got an IP address, I've got a subnet mask, I've got a default gateway, and I've got a DNS server. Here we're using Google for DNS, so we expect that to work. But of course, to be able to connect to the DNS, I connect through my default gateway. So let's try to ping pack.zscaler2.net, where we get our pack file from, so that's working. We can ping mobile.zscaler2.net, which is where we get our mobile configuration from, and we could ping login.zscaler2.net, where we're going to authenticate for Zscaler. So as long as we're getting DNS resolution and we're routing and we're getting responses back from ICMP, we know we have connectivity to the Zero Trust Exchange. We should also check for Zscaler private access, so we could ping samlsp.private.zscaler.com. So we can resolve that, and you see this is resolving to what's called a broker. We're resolving to Chicago and the global server load balancing address. So that's working okay. And so we have the client available, and we could do a couple of things at this point. So what I'll do, I'm going to start with downloading the Zscaler client, because this is where we're going to initiate our problems, let's say. So if we install, download the MSI, and let's just install it as a one-click. Again, if you don't have the right rights on the machine, you're not going to be able to install the client. So we need to make sure that it's either installed programmatically or you've got administrator access. To install the client. Once the client installs, then we're going to need to run through authentication. Now this is where the first set of problems could occur if you installed it programmatically and you installed it within the installer options of your cloud name and your domain name. If you don't enter those details correctly, you could end up targeting the wrong cloud or having the wrong cloud instance or tenant name. So if I try to log in and I make a typo here as Welsh, instead of Welsh Geek, I misspell the name, we're going to get an error here saying it's not subscribed. So a not subscribed error tells us that there's a problem with the username, not so much the username, but the domain name that we've entered in this. Now, I could enter my real domain name, and it's going to go off and it's going to talk to the cloud and say, right, how should I authenticate? And it should have prompted me for a cloud name. So it's important to know that Zscaler operates on multiple clouds. So if I was to put in here, let's say ZDX preview, now let's do zspreview.net and click save. Let's do Zscaler beta.net, click save. Oh, it doesn't like the net on the end. I'm going to Zscaler beta, click save. And click login. If I've connected to the wrong cloud, it's going to say I'm not subscribed to that one either. So you've got to make sure that you're selecting the right cloud. Let's go to net and click login. And it's now able to authenticate me. If we change this cloud name, let's get rid of that, clear, click save. This point it's going to prompt me for which cloud I want. So you always have to make sure you're selecting the right cloud, and that's why we use those installer options, and it's important to make sure those are correct. So now I'm going to select Zscaler 2. It's going to redirect me to the IDP, and I'm going to authenticate. So you could end up with authentication errors against your IDP. Is the IDP available? If you're using something on premise like ADFS, if the user is on the network, is the ADFS server available? If they're off the network, is your ADFS proxy available? So your IDP needs to be available to sign into the platform. So I'm going to pause there, and I'm going to jump through the steps that we can do to look at that authentication. So we'll start with what happens when you enroll with Zscaler Internet Access. So remember, there's two different flows, one for ZIA, one for ZPA, when you enroll with Zscaler Client. So we'll come over to our browser here, and we'll place this URL. The URL identifies the cloud that I'm on. Twice, it needs to be in there, and then the domain that I want to authenticate to. And so what I will do is I'll have a look at the web inspector here. I want to make sure I preserve the log, and I'm really interested in the documents that are passed back and forth, none of the JavaScript or anything. So we'll simulate the client enrolling. It's probably my username. I've entered my username. This is all part of you can see the SAML 2 flow here is on the Microsoft platform. So this is Zscaler initiating the SAML SSO. And I enter my credential here, and the login completes. Might well ask me for multi-factor authentication. And we are good. Okay, so we've authenticated. So we had the SP initiated SSO. It redirected to SAML, and we can see the payload here. This is the payload of the authentication request, and then authentication completed, and then it posted the authentication response. And in this case, it was successful. But what we're going to do is we're going to take a quick look at how these two look, and make sure that we understand the flow so that we can diagnose any problems. So what we'll do, we need to highlight it all, and I find it's better to use the inspector process rather than using any kind of installer or plugin, just because you're getting the raw data. So if we come across here and we go to SAML tool, so for SAML tool, here's one here, and we can go, let's log into SAML tool. Any number of these available out there. And what we want to do is we want to decode the SAML data and inflate it, so we can paste this in there, decode and inflate, and we see here, so it came from Zscaler 2, or it was going from Zscaler 2, and we were going to Microsoft, so we make sure all of these things look right. It's an unsigned authn request, there's no signature in here, and so the IDP just needs to authenticate the user. So that's all fine, we got redirected correctly, the user authenticated. So let's have a look at the response. And so we have all the data here. Again, we'll copy the data. Paste it in there, decode and inflate the SAML. So now we have a lot more data coming back, and we can see the response, the destination. So that destination is correct. It needs to be 443 SFC SSO. We see where it's come from, and at this point we can see the signature. So the signature was correctly signed. This is jumping around a little bit too much, but we can see the certificate in here that it was signed with. So if there's any problem with the certificate that was uploaded to Zscaler, you can see it in the SAML response as to what the valid signature is and the valid certificate. So we could always export that and upload it if we wanted to. And then important things that we're looking for here is the name ID, and making sure that the name ID matches the names available in the Zscaler interface. So specifically the domain name, my domain name here is welshgeek.net, so the domain suffix for the name has to match a domain suffix that's available on your tenant. We've also got date and time in here, so if your IDP has a time sync problem, then you need to make sure that that's correct. I've seen a couple of instances of that, less so with things like Azure AD, but authentication errors do occur. And then if your attributes, if your policy isn't being applied correctly in ZIA, because the groups haven't been sent across, you can see all here the attributes that were sent across, my display name, my department, and then the attributes for the groups that I'm a member of. So we can do the full decode there and understand that the SAML was authenticating correctly for Zscaler Internet Access. Now the same is also true with Zscaler Private Access, different URL, and we'll do an inspect for that as well, because I think it's important to see the distinction between the two. So here we'll do an authentication. I'll enter mryan at welshgeek.net. We go through the multi-factor auth. Zscaler Private Access behaves slightly differently. It'll actually display a pretty version of the assertion and the attribute values. But again, we see the login, we see the authn request. Now this time the payload is slightly different, so let's just take a look at that. You see it's bigger, it's a bigger payload for the authentication request. So if we paste this in here and we decode and inflate it, so here we see the authn request, and we can see that it came across, it had force authn equals true, so that's why I was prompted to enter my username and password. So again, if the question is a user experience problem, why did the IDP authenticate me in that way? These are configuration options in the IDP configuration in ZPA. We did post binding, which is correct for ZPA, And we also, in here, we see a signed authentication request, or auth-n request, has a digital signature, and again has a, because it's signed, the IDP will validate that signature, or should validate that signature. Now it's important to realize that this is a bigger assertion, and this is why it's important to use post binding. If you use redirect binding or a get method, this would cause a problem on your authentication. So looking at the capture, looking at what the IDP supports and how the browser treats these different methods is important to diagnose the authentication process. But we know that we got redirected. If we come across here and we look at the payload on the response, again, we can highlight all of this text. We can put it into the decode. And we can see the response again. So the destination, that it was a success by the IDP, and we can see the signature, and we can see the certificate that was used to sign it, sent by the IDP. Again, we can see the user principal name in here. We've got the date and time, and we've got all the attributes that were then displayed nicely in the response. So we've diagnosed the authentication process with Zscaler Internet Access and Zscaler Private Access. So if we come back to our client and did the same thing, we can expect that if we had those installer options, Zscaler 2, we've authenticated, so we know that this will succeed because the SAML trace has shown us that it will. Let's try the authentication again, now in Zscaler Client. So we click Login, it'll prompt me for the cloud. Again, if we installed with the installer options, these two pages should be transparent. So I'm asked to enter my credentials here. And if I was on my trusted network or as a domain joined machine, these authentications should be transparent. So I enter my credentials. I'll get my MFA sent to my mobile device. So there's Zscaler Internet Access first. Now the force auth-n was sent by private access, so I'll need to log in twice because of the configuration of Zscaler Private Access. So I'll enter my credentials there as well. And of course I could update these settings in my IDP. These are both IDP configurations as to when force auth-n is needed, when multi-factor is needed, and if obviously it was a domain joined machine, I would enroll transparently. So at this point, So now the Zscaler client is installed. Let's open Zscaler. We actually have connectivity here. Zscaler Internet Security and Digital Experience is connecting as well. So we're enrolled correctly. But it'd be worth checking to make sure that we've got all of our policy enabled. So we can take a look at the logs. We can go to C:\program data. On a Windows machine, we can have a look in the Zscaler directory, continue. And we see we've got a number of files that have been created during the enrollment. And the main thing that's kind of interesting to us is this ZSA tunnel for the minute. What we'll do let's load that file up. We'll take a look through this this log file that tells us that it updated and installed and how the authentication process worked. Now remember, we did a number of different things in here, and it's telling us about the network adapters and the routing and everything that's going on there. So let's take a search in this thing. We're looking for pack files because that's the first thing that Zscaler client will do, is try and download the pack file. And this was the pack file that it tried to download, which is the application pack file that I configured in my application profile. So we know that it downloaded the pack file. We could take that . We could curl that pack file just to make sure that it is downloading correctly. And in the pack file we have the variables. In this case it auto-completed those variables with the closest available Zscaler nodes, Chicago and everything. And we can test this. We can come into our browser here and we can go to ip.zscaler.com. And we can see this tests two things. The first thing is to prove that traffic is being tunneled. The second thing this gives us is information about the node that I'm going through. You see 1022. know, we came in via 1024, but it's a virtual IP address and it load balanced the traffic. But we egressed with 10.166 because there's a number of instances within the pool of nodes in the Zero Trust Exchange. Tells us that we're going through Denver, ZS2 DEN, Denver, third data center, and the specific instance that we're going through. And then the Zscaler node sees that my real IP address is 206.198.150.53. So that's the IP address that I'm egressing onto the internet with. And we can look at this, we can see environment variables here that are in the request that's received by this web server. So it sees that Zscaler added an X forwarded for header. That's the real IP address I'm originating from. And this is the real IP. This is the IP address that the node sees us coming from. So we add a couple of headers, and we can see the traffic all the way through. So from a Zscaler internet access perspective, things are working. Let's take a look whether or not policy is working. So I might see a policy block, and I can understand why that policy block is now applying. The policy block is because of the rule, but the rule might be based on the group membership, and that's why we're looking at the SAML to make sure the user is in the correct groups. So if we come now into admin.zscaler2.net, we can see the information for the user. Let's take a look at user management. We know that Mark Ryan was in those groups because those were consumed via the SAML authentication process. If we look at our URL and Cloud App Control policy, we're actually blocking here. We could override, because we have an override password. We could click that and go through the override process. Interesting. Believe this is because of the SSL inspection. So we can check here. Certificate is not valid. So it's been blocked by Chrome because of the issuer certificate. So I'm using a private certificate authority here, and it looks like Zscaler client did not install the certificate. So we have two options to resolve that. We can come into the portal here. Let's go to Client Connector Portal. We go to the app profile. Here's my policy here. And it says install Zscaler SSL certificate is marked as no. So let's go ahead and install the Zscaler client certificate and click save. If we come in here and we go more, update policy, it should go ahead and install that certificate. So let's refresh this page now. So we can have a look, and this is where making sure that certificates are installed correctly. You might want to look at the certificates here. So we look for certificates for the current user. We'll click OK. So here's my certificate list, and it's installed the Zscaler certificate, and it's installed the my Welsh Geek certificate as part of that. Details, certification path. So let's take a look at this certificate. So certificate is not valid. Details. And so we have a certificate for Microsoft, signed by the Welsh Geek in temporary intermediate, signed by the Welsh Geek intermediate. And let's have a look at the issuer for this. So that's Welsh Geek DC2, welshgeek.net. So there's a problem here as to why that's not working. So let's close down the browser and open the browser again. And let's go to 888.com again. We'll click the reauth. And this time it worked correctly. So the browser still needed to be refreshed, closed and reopened to reload that certificate store. So whilst there are a bunch of things which are Zscaler functions, there will always be something client-side, or often there's client-side things that need to be updated. So now I can re-authenticate. Let's do that. And this will probably prompt me for MFA again. And so this function of password-based override means that I can re-authenticate as an administrator at that point to be able to get through block pages if I need to. So generally this might be used in schools, for example, where a teacher needs to override authentication. Okay, so we've troubleshooted, we've seen what's happened, why a website has been blocked because of the untrusted certificate. How do we look at those certificates? How do we revalidate those? So let's come back across. I'll jump into my browser here. Might be a bit easier to see. Okay. Okay, so I'm logged in. I can see some traffic. We can see the users. We can start to analyze this chart and see what the user's been looking at. Let's take a look at URL super categories. We see some bunch of things in there. We can have a look at URL categories, so we know that we went to some gambling things in there. Let's take a look at the actions. We see things were blocked, and so let's drill down and look at the raw logs. So there's a bunch of things that were blocked that we didn't even see things for. So there's a compliance category. So this is a DLP rule has triggered. And the DLP rule triggered because I have a custom pattern configured, which is clearly incorrect. So there are blocks going on in the background that you just don't get to see. So that's where we can go and have a look at our DLP policy, and we can say, okay, well, our rule that says it was blocked by the custom category, we can go off and take a look at that. But we know that a couple of minutes ago, let's go for the last 5 minutes. Let's go to logs for the last 5 minutes, where the web action was a blocked with caution. We click apply. Let's just say allowed with caution. Well, let's just clear that and click apply. Okay. So we see the request. So we could come in here and we could let's filter based on the URL search, and we say that the host name contains 888. Now this isn't a very efficient search to do, but we'll do it anyway because we've got very few logs, and we can see that the user Ryan was not allowed to browse this category because it needs an override, and then we see that the override was provided. And at this point we start to see more information in these logs about how the inspection provided, the client's IP address. This was the client IP address provided by Client Connector. We see that external IP address of the user, which we saw in the ip.zscaler.com, and we see information that was collected by the Client Connector about the platform that I'm on and device information, and we also see that SSL was inspected. There are more columns available here, and of course all of this can be streamed through the log streaming into your SIM for analysis there as well. Okay, so we've got a couple of things there. We've shown the enrollment process, we've shown the connectivity, we've checked DNS, we've checked through the authentication enrollment process, we've shown connectivity to the Zero Trust Exchange for internet access, and we know that the client is connected for private access because Zscaler Client Connector downloaded that configuration. So let's take a look at some of the client forwarding things. So we're now trying to access a private application. So we're going to start with something as simple as a ping, dc3.welshgeek.net. I know that's my domain controller. And you know, ZPA by default blocks the ICMP, so I'm not worried the fact that I didn't get an a ping response. What I'm looking for is the fact that it resolved to a 164 address, and that worked. I could do something like a curl dc3.welshgeek.net cert serve, and we'll put a -v on there, and we see that we got a response. So we're interested specifically in two things. The first thing is, did it resolve? Yes, I got an IP address. Could I make a TCP connection? Yes, I made a connection to port 80. And what was the HTTP response that I got back? And in this case it was a 401 unauthorized. So and it says authenticate negotiate and authenticate NTLM. And so if I go ahead and I open up my web browser here, I could go to http cert dc3.welshgeek.net cert serve, and I'm going to do the web inspect, and we'll see all things going on. So if we press enter on this, we expect the same thing to happen in the browser, and now I've got this pop-up, and the pop-up is because I couldn't authenticate. This machine isn't domain joined, it's not able to actually authenticate. So here I'd actually enter mryan@welshgeek.net, enter my credentials, and then I'm authenticated. So we can see the information here. If this was a domain joined machine, that authentication would be transparent, provided the authentication and the connectivity to the domain controller is all working and everything there. And so this has proven the connectivity end to end between my client, Zscaler private access, so the Zero Trust Exchange, and the app connector to the Zero Trust Exchange. So all of this is proving things are working. So let's take a look at a couple of things that we could do to troubleshoot a bit further. So I get onto the connector, So this is the connector in my data center, and so I need to be able to ping dc3.welshgeek.net from there, make sure that that's working. And of course it's important to make sure that this is the real IP address, and that goes along with checking that the DNS server is configured correctly on my app connector. So making sure the app connectors are configured correctly, they're able to do DNS resolution and things like that. It's also important when you are looking at things like authentication, Active Directory, Kerberos and things like that with domain joined machines, they need to be able to perform not just DNS A record lookups but also SRV records. So for example, dig SRV for _LDAP._TCP.welshgeek.net. This is saying what in the welshgeek.net domain, my Active Directory, what is the TCP server that's running for LDAP, or what servers that are running on running LDAP are listening on TCP. So this comes back and it tells me the actual domain controller is DC3, it's on port 389 for TCP LDAP, and it's priority 100, priority 0, wait 100. And then it also resolves it here. So for things like Kerberos to function correctly, you need these SRV records looking. So if we come back to our client PC here, and it's a Windows machine, so we can't do that. We can do NSLOOKUP. And so if we do dc3.welshgeek.net, we get that response, 164.1.5. If we do set type equals SRV, and then we do _LDAP._TCP.welshgeek.net, we expect that DNS resolution to occur, and it's saying, okay, exactly the same answer, dc3welshgeek.net, port 389, wait 100, priority 0, and then it does the A record lookup and it says it's DC3 and that's 164.1.5. So those things are important within private access to make sure that DNS SRV records are being passed correctly, not just those A records. And all of these come down to app segments. So if we have a look at our application segments, I've got my domain controller defined as DC3, but I need this wildcard segment, start@welshgeek.net, to occur. If I go ahead and let's say disable this application segment, we click save, and we come back across to this client machine and do the same lookup, you see it fails. It fails because the wildcard didn't match to enable this SRV lookup to occur, even though dc3.welshgeek.net is still available. It should still be available. It's because it's DC3 is a C name for welshgeek.net, so it wasn't resolvable there. But I could, yeah, that's why that didn't resolve. But the number of, by understanding how your domain name structure looks internally, it's important to have these things understood and configured so that we can actually access these applications. So we've shown DNS resolution, we've shown applications can resolve, we've got app connectors available, we've also got our diagnostics tools here. So we can see all the logs for those connections. DC3 is a UDP connection, some TCP connections to port 80. We also can look at trend information, how transactions are looking across the time period. We can look at app connector statuses and see how those look. They're all connected. I've got my connectors. I can look at a dashboard level and see my app connectors, show the number of tunnels that are connecting through there. I can look at applications are available, what the memory utilization, have I got any performance problems within those app connectors. If I had private service edges deployed and they were available, I would see the traffic there, and I can see the user connections and things like that there. So if I'm looking for specific users on challenges, I can come into diagnostics. Let's extend this range for a bit longer. We might start to see some errors in here, possibly. I see some policy blocks because the user has timed out and they needed to re-authenticate. At this point, potentially this could be a problem. I couldn't access the ADFS server because of a policy block, and if I was authenticating against ADFS, then I have a real problem. I can't access the thing that I need to authenticate against. So I need to build policy around to allow that level of access. And then we can do things. We can come into support information. What I want to do is I want to add a session for an app connector. And really, this is to avoid that SSH on there. So let's try our TCP to the DC3. And so I'll select my app connector, my Milton Keynes one, and I want to do a DNS lookup for the SRV record, and the SRV record is _ldap._tcp.welshgeek.net, and this is specifically asking that app connector to go off and do that DNS lookup. And remember, if I had multiple app connectors in multiple geographies, I can ask all of them to do that same lookup. So let's click save on that one. It'll auto refresh every 60 seconds. It'll take a little while to run. Let's just refresh. I have only asked it to do one app connector, so it shouldn't take too long. And we can look at this data. We click here and it says, okay, I asked it to look up _ldap_tcp welshgeek.net, and it came back and it said 0, 100, 389, and it's dc3.welshgeek.net. And then it tells us about the information, and there was no error. So I can programmatically ask my app connectors to go off and do DNS resolutions and make sure those are applying correctly. And so with that, we've gone through how ZPA connectivity works, how ZIA connectivity works, the authentication process, and the connectivity. Now, of course, there are other problems that are of interest, so we can go ahead and we can do a couple of other things. So if I was trying to troubleshoot a problem, of course, HTTP headers and HTTPS headers are important for us to understand what's going on inside the payload. But we can do things like take packet captures within the Zscaler client connector. So if we start a packet capture, we could reproduce the problem, whether it's a public connection, a private connection, and those will be captured here in those packet captures. So we stop the packet capture, and then we can go off and we can export the logs. Here I'll just drop them to my desktop and click OK. So Zscaler Client Connector will grab all of its logs, wrap them up, including those packet captures, export them to a file that you can then submit to Zscaler support. It's just taking a short second to compress all those logs. And now if we look on the desktop, we've got our compressed file there. Let's take a look in this. So it's grabbed all the information about the client machine. It's also grabbed things like group policy objects, installer information, and we've got all of the data there. Interesting. I don't see the packet captures there. Let's go across to Zscaler program data. Zscaler. There are the packet captures there. It's only because we don't have Wireshark installed there. So let's go ahead and install Wireshark. We'll take a quick look through those packet captures. So we can download Wireshark, Windows installer. To install Wireshark, let's go ahead and open this packet capture. So the LWF is everything that's kind of going inside of the tunnels. So for example, let's take a look at IP address 164.1.0/24. So everything that's a ZPA segment should be in there. And so we see the HTTP request, we see a GET request, and we see the response. So we can see everything that was going on with things inside of the tunnel. And that tells us we've got connectivity. What's also interesting is if we do DNS, so we can see that it was trying to resolve Zscaler 2. Here we did a query for welshgeek.net DC3, and then we got a response back that says 1.5. So we can see all the DNS queries in there as well. If we go ahead and we say TCP port 80, we know we did a lookup for, and we went to go and get ip.zscaler.com. So here is that request, ip.zscaler.com. Right click, follow that TCP stream, and we see the connection and the response back. That's gzip encoded. So we see a bunch of data that's coming back from that. Contrast, the adapters packet capture is things that are going on outside of the Zscaler tunnels. So slightly different. We see the DTLS tunnel. So this is encrypted, so you can't see in it. So it's worth filtering that out unless there are problems in there. So we can say not DTLS. But it does tell us things that are going on outside of the tunnel. For example, the actual TLS connections for downloading, the connection to Zscaler for pulling more data, the actual policy information. Here we see a 407, a proxy unauthorized. So we can see information about what's going on outside of the tunnel. Now invariably a lot of this data is helpful to look at, but also helpful to submit to the support ticket if you can't diagnose problems yourself. So I'd always recommend when we come into a real troubleshooting problem that you need support from Zscaler, you do a couple of things. We come in here, we'll say let's clear the logs because we know everything's working at this point, and so we start with a clean slate. We then go and reproduce the problem. You might even want to restart your network adapter because we'll clear the DNS cache and the MUP cache and the different things that are system settings, then reproduce the problem. And then what we'll do is you can export the logs, take the packet capture, reproduce the problem, export the logs, and then you've got a full bundle of a clean state of the logs, the problem being shown in the logs and the packet captures, and then you export the data and we can review that. And you can also look at how those logs, if you take a look at the packet captures, what traffic went to ZIA, ZPA, ZDX, to be able to then diagnose those problems and produce a solution. So with that, I think we've gone through diagnosing the end user device, the local network, the internet, the zero trust exchange, the application segmentation. We've gone through looking at the logs both in ZIA and ZPA. We've looked at the logs inside Zscaler Client Connector. We've looked at packet captures, and we've looked at those flows for the authentication. So we've taken it all the way through from initial install all the way through to application connectivity.